Next, we'll look at the limits of the form 0 over 0 and infinity over infinity. So what does that imply? It implies that after you substitute the value that s tends to into the function, you got the numerator to be 0 and the numerator to be 0. As well as when you substitute the value, you got infinity over infinity. So in that case, we need the following note before we proceed. So the first is to note that whenever you are taking the limit of a constant over x as x tends to 0, if you substitute the value that x tends towards here, you're going to have a over 0. Okay, any constant over 0 implies that what this is undefined, and it means that the limit does not exist. Okay, so next, the limit of x over a as x tends to infinity, if you substitute the infinity for x, so it implies that it is undefined as well, that is, the limit does not exist. It's just like you have a very, very large value divided by a constant. So your result will still be very, very, very large, which is undefined. Okay, so it means that the limit does not exist. Now, the limit of x over a as x tends to 0 implies that we have 0 over a. So 0 divided by a constant, that gives you 0. And the limit of a over x as x tends to infinity, you have a over infinity, meaning that you are dividing a constant by a very, very large value, and the value will be tending towards 0. So this is the limit equals to 0. So that means the limit exists for these two cases, but for these two, the limit does not exist. Okay. Let's take for example on the limits of the form 0 over 0. Okay. So we saw that is indeterminate. Okay. So we take the first one. Limit of x squared minus 9 over x minus 3 as x tends to 3. And if we follow the definition, we substitute directly for x. So if we do that, we're going to have x squared minus 9 over 3 minus 3. So this will give us 9 minus 9 over 3 minus 3. And this will give us 0 over 0. Okay. So whenever we have this, then it means that we have some other ways of solving this, of getting this done. Okay. Because indeterminate means that this can be written in other constants. What we now do, we write the question back, x squared minus 9 over x minus 3. Okay. So what we do is we try to look at this expression in the numerator. So that look like something we can write as limit as x tends to 3, x squared minus 3 squared. Remember that 3 squared is the same thing as 9. Okay, that's beautiful. So what we do next is to apply our knowledge of difference of 2 square. Our knowledge of difference of 2 square. Look at this now. We have a square here, and we also have another square here. So difference of 2 squares. So and that is written as x minus 3 multiplied by x plus 3 divided by x minus 3. So now x minus 3 can take care of x minus 3, and what we have left is the limit as x tends to 3 of what? Of x plus 3. Okay, so we can now substitute. Wherever we see x, we can now substitute 3, so that we have 3 plus 3, and that gives us what? 6. So the limit of x squared, minus 9 divided by x minus 3 is equals to 6. Okay. So the second one, we also have the limit of x squared minus 4 over s cubed minus 8 as x tends to 2. It's supposed to be x tends to 2 here. Okay, as x tends to 2. So also, if you substitute directly, you're going to have 2 squared minus 4 over 2 cubed minus 8, which is 0 over 0. So next, what we do is to factorize both numerator and denominator. Okay, so we have the limit as x tends to 2 of x squared minus 4 over s cubed minus 8. Okay, so this is equals to the limit as x tends to 2 of x minus 2 x plus 2. Okay, but from our knowledge of difference of 2 squared. Okay, now here we have s cubed minus 8. If you observe, if you substitute 2 for x here, the one that will lead the numerator to 0 is x minus 2. So what we do is we divide the numerator, from our knowledge of division of polynomial, we divide the numerator here by x minus 2. Okay, so let's quickly do that. Division of polynomial, s cubed minus 8 divided by x minus 2. Okay, so if we do that, we're going to have s squared first. So multiplying that, we have s cubed minus 2x squared. Okay, subtract. If you subtract, you're going to have 0 for this, and then here you're going to have 2x squared. Bring down the constant there, that is minus 8. Again, so what can we multiply by? We multiply by 2x. So 2x times x, that will be 2x squared, and 2x times minus 2, that will be minus 4x. Okay, subtract again, that gives you 0, and this will become plus 4x. Bring down the 8 as well. Then what we have here, we need to multiply by 4, okay? 4 times this, that will give us 4x minus 8, and this goes down to 0, okay? So it means that the denominator, x cubed minus 8, can be written as x minus 2, our divisor, multiplied by x squared plus 2x plus 4. Okay, so x minus 2, we cancel x minus 2, and what we have left is the limit as x tends to 2 of x plus 2 over x squared plus 2x plus 4. So wherever we see x and we substitute 2, if we do that, we're going to have 2 plus 2 divided by 2 squared plus 2 times 2 plus 4, okay? Simplifying this, we have 4 over 12, because here we have 4 plus another 4 plus another 4, that is 4 times 3, which is 12, and this will be simplified to give us 1 over 3. So the limit of x squared minus 4 over x cubed minus 8 is 1 over 3, okay? So remaining the last one, so let's try to substitute directly. If you substitute directly, you're going to have 0 over 0, okay? So what that implies is that there are other forms of writing the function, okay? So what I do is to factorize the numerator, factorize the denominator if it is factorizable. So we have the limit of, okay, denominators. Let's try to factorize. Recall that we can, you multiply the coefficient of x squared by the constant term. That means we have minus 1 times 10, that is minus 10. Then we now find two values. Two values we multiply together to give us minus 10, and when we add together, we have minus 9, okay? So that will give us minus 10 plus 1. So that we can write this as 10 minus 10t plus 1t minus t squared divided by, for the denominator, the coefficient of t squared is 3. The coefficient of t squared is 3, multiplied by the constant time, which is minus 7. 3 times minus 7, that gives you minus 21. So what do you multiply together to give you minus 21? And when you add together, we give you plus 4, okay? So minus 21 plus 4, that will be plus 7 minus 3. Plus 7 minus 3. So that we have 3t squared plus minus 3t plus 7t minus 7, okay? So now we can factorize as t tends to 1. So we have the limit as t tends to 1 of, okay, try to factor out. 10 is common here, factor it out so that we have what left? 1 minus t. Then t is common to the remaining two terms. That means we have plus t, and what we have left? 1 minus t. In the denominator, what is common? We have 3t to be common, and what we have left? We have t minus 1. So to the other side, the other two terms, what is common? Plus 7 is common, and what do we have left? T minus 1. So we go further to say that this is the limit as t tends to 1. Okay, so t minus 1 is common, we factor that out, and then what we have left? We have 10 plus t all over what is common. T minus 1 is common, and what we have left? We have 3t plus 7. Okay, but recall that 1 minus t can be written as minus t minus 1. Okay, so that we have 10 plus t divided by t minus 1 multiplied by 3t plus 7. Okay, t minus 1, we take care of t minus 1. So what we have left? We have the limit of minus 10 plus t over 3t plus 7, okay, as t tends to 1. So wherever we see t now, we can replace with 1, okay, so that we have minus open bracket t plus 1 over 3 times 1 plus 7, okay. Simplifying this, we're going to have minus 11 over 10. More example on limits of the form 0 over 0, okay. So we take the first example. We have the limit as the limit of x minus 4 over root x minus 2 as x tends to 4. Okay, we are going to solve this problem using two methods. The first is to factorize, and the second is to rationalize. Okay, so using the first method, we want to factorize this. Okay, we recall that x can actually be written as root x squared. Minus 4 can as well be written as 2 squared, okay, divided by root x minus 2, okay. So here we now have difference of 2 squared. So having difference of 2 squared means that we can what? Factorize, okay. So if we factorize this, we're going to have the limit as x tends to 4 of what? Root x minus 2 multiplied by root x plus 2 divided by root x minus 2. So root x minus 2 will take care of root x minus 2, and what we have left is the limit as x tends to 4 of what? Root x plus 2. We can now substitute directly. Anywhere we see x, we substitute with 4. So that we have root 4 plus 2, and that will be 2 plus 2, which is equal to what? 4. Now, that is one method. Another method is to rationalize. So to rationalize this, it means we have the limit x tends to 4, then we have x minus 4 divided by root x minus 2 multiplied by 1. And that one will now be written in terms of the denominator that contains the rational form. Okay, so that we have root x. So the conjugate of this denominator, will form 1. Okay, so we are going to write as root x plus 2 divided by root x plus 2. And recall that is 1. Okay, so if we multiply this, so we're going to have, to multiply that, we have the limit x tends to 4. So if you multiply that, you're going to have x minus 4 multiplied by root x plus 2 divided by 2. We now multiply the denominator. If you look at it, the denominator look at the difference of 2 squared, Abi. Okay, meaning that we have something like root x squared minus 2 squared. Okay, so and if we simplify that, that means we have the limit as x tends to 4 of what? X minus 4 open bracket, close bracket, open bracket, root x plus 2 divided by x, root x squared is x, minus 2 squared is what? 4. Okay, x minus 4 will now take care of x minus 4. And what we have left? We have the limit as x tends to 4 of root x plus 2, and which is equal to 4. When you substitute, we simplify to 4. The second example, here we are only going to use our knowledge of rationalization. Reason being that to apply factorization, this will look complex. Okay, so what we do is just to rationalize straight up. Okay, so we multiply by the conjugate of the numerator in this case, because that is where you have the rational part. Okay, so we now have 3 plus root 1 minus x divided by 3 plus root 1 minus 4x. Okay, so with this, if we multiply these two now, we're going to have the limit as x tends to minus 2 of, okay, the numerator looks like difference of 2 squared, and we can write as 3 squared minus 1 minus 4x with the root sign all squared, divided by, here we just have 2x plus 4 waiting for us, and then we have 3 plus root 1 minus 4x. So simplifying the numerator, we have the limit as x tends to minus 2. Okay, and this is 9 minus, if you square this will give you 1 minus 4x. Okay, divided by 2x plus 4, then 3 plus root 1 minus 4x. Okay, I want you to observe that usually after I multiply by the conjugate, I don't usually simplify the product of the other one and the conjugate. Okay, so I normally leave it like that, because at the end, if you simplify the numerator or you simplify the other one, you will have something to cancel out this particular term here. Okay, so we now go further to have the limit as x tends to minus 2 of what? Of 9 minus 1 plus 4x. 9 minus 1 plus 4x all over 2x plus 4, 3 plus root 1 minus 4x. Okay, if we simplify further, we have the limits as x tends to minus 2 of what? 9 minus 1 is 8. 9 minus 1 will give us 8. 8 plus 4x. Okay, 8 plus 4x divided by 2x plus 4, 3 plus root 1 minus 4x. Okay, now if you look at the numerator, something is common to the two terms. 2 is common. You can do something about that. So that we have the limit as x tends to minus 2 of, okay, of 2 open brackets, okay, 2 open bracket, 2x plus 4. So how do I arrive at this? Because I know that addition is commutative, like if I change the position, it will still give me the same result. So we have 2 open bracket 2x plus 4, okay, divided by 2x plus 4 open bracket 3 plus root 1 minus 4x. So now 2x plus 4 will take care of 2x plus 4, and what we have left is the limit of 2 divided by 3 plus root 1 minus 4x as x tends to minus 2. Okay, so now we can substitute directly, and if we substitute, whatever we see x, we put minus 2. We're going to have 2 over 3 plus root 1 minus 4 multiplied by minus 2. Okay, Minus 4 multiplied by minus 2 will give us plus 8. So plus 8 plus 1 will give us 9. Okay, so that we, okay, let me conclude it here. So that we have, that will equal to, if we simplify this, we're going to have 2 over 3 plus root 9. Okay, this will be 2 over 3 plus 3, and that will be 2 over 6. And 2 goes here, 1, 2 goes here, 3. That will be 1 over 3. So the limit is 1 over 3.